Well, this integral, most people will do this integral by Feynman's technique, but now I'm using different methods, so I would like to share with you. Now, this is equal to 1 over sine x, and the arctangent of sine x is considered as arctangent y times sine x. Y is from 0 to y equal to 1, then dx. When y equal to 1 is this, when y equal to 0 is 0. So they are equal. Now, then this one is equal to, well, this is sine x. So this is a definite integral, right? This is the antiderivative of some function. So some function is the integrand function of a certain integrand function, which is the derivative of this with respect to y, that is equal to 1 plus y square sine square x. And the chain rule, right? The derivative of this one with respect to y, this is sine x, then dy. Yeah. This is that. This is this. Then dx. Then I can cancel the sine x, right? And I switch the order. I do x first. So I do y later. Do x first. And this would be dx over 1 plus y squared. So, right? Then dy. Okay. I do x first, then dy. Now, for the integral with respect to x, well, I have to treat the denominator. How should I do? How about this? I change 1 to sine x plus, this is cosine x plus sine x, plus sine x squared, then plus y squared sine x squared. Then this is dx and dy. Yeah. So this one is equal to from 0 to 1, then 0 to half pi. Now that is equal to, well, this one and that one can be combined. This is dx, the cosine square x plus y square plus 1 sine square 1, right? Then dy. Very good. Then here, I divide both numerator and denominator by sine square. Okay, so that would be equal to, I divided by sine square, both top and the bottom. So the top will become, divided by sine square is a cosecant square x dx, right? This one divided by sine square is a cotangent. This divide sign is equal to y squared plus 1. Right? Then dy. Very good. Yeah. Now this, then this one is equal to the numerator is equal to negative d cotangent x. Right? The derivative of cotangent is a negative cosecant. And this way is a cotangent square plus y squared plus 1, right? And then dy. Now, for this integral, we are integrated with respect to cotangent x. Therefore, this is a constant. This is a cotangent square, so we can use the formula of arctangent, right? So this one is equal to 0 to 1. This will be negative, right? Arc, we have a formula. This is constant, right? Arctangent, cotangent, cotangent x over y squared plus 1. And from 0 to half pi, then dx, then dy, sorry. This is the integral for cotangent. Yeah, okay, very good. Now this one is equal to negative. Now this y squared, cotangent to half pi is 0, right? So tangent 0 is 0. Cotangent of 0 is infinity. Infinity for the arctangent is half pi. Yeah, then dy. Yeah, this is right. So this becomes a integral negative with positive, right? Half pi and dy over y squared plus 1. That integral is much easier. We use a substitution, trigonometric substitution, right? Let y be tangent theta, right? So dy is equal to secant square theta d theta. Now my integral becomes half pi, and this will be secant, right? This will be secant theta, and this will be secant square theta d theta. And when x equals 0, well, y equals 0 is 0, y equal to 1 is quarter pi, right? Quarter pi. So this one equals to half integral quarter pi secant theta d theta. That integral is basic, so it's half pi log secant plus tangent, right, from 0 to quarter pi. Yeah, this one equal to half pi natural log secant quarter pi is the root 2, right? And tangent is 1, yeah. Secant minus log. Secant 0 is 1, right? 10 is 0. Yeah, so this is a 0. Finally, this is the answer. Log root 2 plus 1. Okay, good.